Okay, let's see if we can do some of these trig limits. They start us off with kind of a gimme here. This is exactly the form that we need when we're doing the sine over x format. Anytime you have sine of something over exactly the same something as that something goes to 0, then that limit equals 1. This is a perfect match. We don't have to change a single thing about it. The limit is 1 exactly as written. Because, just to remind you, we've been told sine x over x equals 1 in the limit as x goes to 0. And if instead of x this is 4x and this is 2, then that'll go to 1 no matter what. The other limit that we're probably going to see in a few seconds is the limit as x goes to 0 of cosine x minus 1 over x. If you just plug 0 into this, what you get is 1 minus 1 over 0, which is 0 over 0, which seems like it ought to be undefined, but it turns out this limit exists, and it is actually 0. So if we can make that happen, then we get a real limit instead of a does not exist. And that's actually what's going to happen in B here. This bears some resemblance to cosine x minus 1. You can see there's a couple problems with it, like the cosine and the number are in opposite order, and this is supposed to be a 1, not a 2, so clearly there's some tweaking involved here. If we want to see if we can turn this into the form of a limit that exists, well, the first thing we could fix is this is supposed to be a minus 1. Can we arrange that? Yup. We can factor a negative 2 out of both of these. Would be one place to start. And if we do that, we get 2 divided by negative 2 is negative 1. Negative 2 cosine x divided by negative 1 is just cosine x. And then we have x downstairs. And hey, look at that. This is precisely what we need to get a limit of 0. So the overall limit here ends up being negative 2 times 0 equals 0. The negative 2 ends up not mattering. It didn't change the value of our limit, but the fact that we were able to get it to this form means the limit exists. It's not just an impossible division by 0 like it might appear to be at first. Let's see what we have here. 2 sines. This is a little bit new. I'm not sure that they ever did this. They may have done this once in the practice problems. They're saying theta goes to 0, sine 4 theta over 3 theta. I'm going to write that like this for reasons which might be obvious already, or they might become obvious in a second. Each of these sines could fit the form sine x over x as long as we get a theta under it. So this sine needs a 4 theta. We're going to add some things here. This section would be fine as long as there were a 4 theta in the denominator. Well, we can do that as long as we balance it out by putting another 4 theta in the numerator someplace. I'm putting this one off to the side. I don't want it to be in either of these sine fractions, but I need to put it someplace. So there's a 4 theta that is just extra, and we have to take care of it. This 4 theta means that this entire fraction is going to go to 1. How about this one? We have sine 3 theta. That limit would exist also if we had a 3 theta in the numerator. And I can just put that there, provided that I put another 3 theta someplace else. So now we have this piece which goes to 1, this piece which goes to 1. Here the thetas cancel and we get 4/3. So overall our limit here is going to be 1 times 1 times 4/3 equals 4/3. All right. And finally, here we have another sine. This one would work out all right if we had sine 3x over 3x. I'm just going to pull this apart for a moment. 3x squared plus x. The simplest way to make this work is just put a 3x here and put a 3x here. The other option you have there's a common factor of x in here, and I'll bet what they expect you to do is to say this is sine 3x times 1 over, pull an x out of here, 3x plus 1. And now that you have that, you can take the x, multiply the top and bottom by 3, and now we get 1 times 3 over, if x goes to 0, this becomes 0 plus 1, and so overall our limit is 3. That's the kind of cute way to do this if you want to show off how good you are at factoring. Here, and that gives the result 3. I'm just going to run this again a simpler way that you might like better, and you can choose which one of these you prefer. This is maybe a little less elegant, but it's simpler, and simple is good too. So I pull this apart into two sections, 3x squared plus x. Now, just as with the previous example, we need a 3x under this for the limit to exist. So I'm going to say 3x down there and 3x up here. And now we get this section which goes to 1. And in this section we have 3x over, we still have to factor an x out. Actually, that's not true. We can just divide by x. 3x plus 1. One way or another, you have to divide the top of this and the bottom of it by x, and then you discover that you have 3 over 3x plus 1. And then when you take the limit, you get 1 times 3 is 3, divided by 1 is 3 when x goes to 0. So the factoring and then moving an x over is maybe a little overcomplicated, but either way you're going to get a limit that goes to 1 multiplied by a factor of 3, and this piece, which when x goes to 0, the 3x vanishes and it just becomes 1, so it doesn't matter for all that much. Overall, your limit is 3.